So what I have to share with you guys here is a simple flow chart that allows us to easily utilize or easily remember how to use Avogadro's number and molar mass in order to convert between atoms, moles, and mass units. So what we have is the mole kingdom. This is actually a flowchart that was presented to me by Mr. Hartman, my high school chemistry teacher, and it allowed me to easily remember what I was supposed to do. So what are we expecting here? Well, first things first, we need to know how to actually use the components that are in the flowchart. So first thing we need to look at is what we have. So on the right-hand side, mass land. This is referring to a unit that is in grams or kilograms, some mass measurement, okay? Inside the kingdom are the units of moles. So if you are in the kingdom, the unit that you will have associated with your number will be the mole. On the left-hand side here, we have atom land. And in atom land, your units will be molecules, atoms, ions, things of that sort. Now, to interconvert between these three units of measurement, we're going to use either Avogadro's number or molar mass. And the unit that we use will depend on where we are positioned with respect to the flowchart. For instance, if we start in mass land and want to go into the mole kingdom, we know that we are going to use molar mass. Now, if we are in atoms or molecules and want to go into the kingdom, okay, we're going to use Avogadro's number because of the position in the flowchart. So, that's pretty straightforward. Now, the feature of the mole kingdom that always helped me get my conversions correct was the idea that in order to get into the kingdom, whether you're coming from mass land or whether you're coming from atom land, is always going to require you to divide. Why? Because in order to conquer a kingdom, you must divide and conquer. Okay, so anytime you're going from one of the lands into the kingdom, you will be using division. Okay, now, you will be using division with either molar mass or Avogadro's number. And the use of the molar mass or Avogadro's number depends on if you're starting in mass land or if you're starting in atom land. Now, the opposite of this is obviously if I'm starting in the mole kingdom and I want to get out of the kingdom into either atom land or mass land, I must multiply. So the mathematical function that you will use anytime that you're leaving moles and going into one of the lands is going to be multiplication. So if I'm going from the mole kingdom into mass land, I'm going to multiply by molar mass. If I'm going from the mole kingdom into atom land, I'm going to multiply by Avogadro's number. So this is the basic premise of how we're going to be utilizing this flowchart from here on out. So what we're going to be looking at here are the conversions between grams and moles, and we're going to utilize something called the mole kingdom. This was introduced to me by my chemistry teacher in high school, Mr. Hartman, and was really useful throughout all of my chemistry studies. So what we have here is essentially just a flow chart. In the middle of the flow chart, or in the middle of the kingdom, you will be in the unit of moles. So it's called the mole kingdom because anytime you're in the kingdom, you are in the unit of moles. On the right-hand side, we are in mass land, so the units that you expect to have on this side of the flow chart are grams or kilograms, things of that sort. On the left-hand side, you're in atom land. On this side of the chart, or the flow chart, you're going to be in molecules or atoms or potentially ions. So this flow chart is readily used when you're converting between any of these three units. Okay, so right now what we're going to focus on is the right-hand side of the flow chart. So we're going to look at converting between grams and moles. Okay, and in order to convert between grams and moles, we must use molar mass. So whether we're going from grams to moles or from moles to grams, okay, whichever direction we're going, the unit that we're going to be utilizing is the molar mass of whatever substance we're converting. Now, if we are going into the kingdom, anytime we enter the kingdom, we are going to be dividing. So the way Mr. Hartman shared it with us is that in order to get into the kingdom, we're going to divide and conquer. So let's actually apply the flow chart here. Now, what we've been given here is a gram to mole conversion question. So what we've been told that we have is we have a 10.2 gram sample of H2O. Now, they want us to tell them how many moles of H2O we have. So what we would do is we would write our given as 10.2 grams of H2O. And the thing we're solving for will be moles of H2O. So, now that we figured out what we're given and what we're solving for, we can subsequently look at our flow chart and figure out what we're going to do in order to solve the problem. So, in the situation here, what we were given was grams of H2O. So, because we're in the unit of grams, we are starting in mass land. Now, I do not want to end up or continue to be in mass land. I want to convert my units to the mole. So, I want to get into the kingdom. Okay? Now, in order to go from mass land into the kingdom, I know that I must divide. Because remember, entering the kingdom means you need to divide and conquer. So, anytime we're going from one of the exterior lands into the kingdom, we are dividing. Now, we are going to be dividing by the molar mass. Based on calculations from the periodic table, the molar mass of H2O is going to be 18.015 grams per mole. So, now that we have our molar mass and we have our subsequent given, we can set up our calculation in order to get the moles of H2O. So, the first thing we're going to do is set up our calculation with respect to the kingdom. So, what we were given was 10.2 grams of H2O. Now, it's always what I've been given in this first box. So it's 10.2 grams of H2O. Make sure you're writing your units and your units of what, so grams of H2O, right? And what we're wanting to do is we're wanting to get into moles. Now, in order to go from mass land into the kingdom, I know that I need to divide, and I need to divide by the molar mass. Okay, so in this case, my molar mass is going to go down here at the bottom. So, 18.015 grams. I'm going to have 1 mole of H2O up at the top. Okay? And the way this works is you simply multiply the stuff that is on the top, so 10.2 by 1, and divide by 18.015. This will give us an answer of 0.56619. Now, our answer is going to have to be dictated by the number in the calculation with the least number of significant figures because we're doing division. So in this case, 10.2 is our number with the least number of significant figures, and that has a total of 3. So our answer here should have 3 significant figures. Remember, leading zeros are never significant. Now, the other thing that we have to consider are our units. Now, a unit evaluation is always going to help you avoid making errors. So we do a unit evaluation basically by making sure that everything that can cancel will cancel. So grams of H2O and grams of H2O is what I have on the top and the bottom. Those will cancel each other out. And moles of H2O is what I have remaining. So my 0.566 will be in moles of H2O. Now, I wanted to convert from grams into moles, as we can see here, and so I've calculated my problem to the correct number of significant digits and with the correct units. Now that we've learned how to get into the kingdom from mass land, let's go ahead and look at how to get out of the kingdom and into mass land. So what we have here is a mole to gram conversion problem. Here we're asked how many grams of H2O are present in 22.2 moles of H2O. So what I was given was 22.2 moles of H2O. Okay, and what I'm solving for is grams of H2O. So basically we're doing the reverse of the problem we saw earlier. So we're going from the mole kingdom into mass land. Okay, so in order to go from the kingdom into mass land, we know we're going to be using multiplication, and we know we're going to be using the molar mass. Now, molar mass, just like last time, for H2O is 18.015 grams per mole. Okay, and just like last time, we're also going to use the same setup. What we were given goes into the first box, making sure that we're including both our numerical values as well as our units of what. Okay, and so we're starting in moles and we're wanting to get into mass. Okay, so what we need to do is we need to multiply our mole value by our molar mass. So in this case, our 18.015 grams of H2O is going to go on top, and our moles of H2O are going to go on the bottom. So in this situation, the numbers on top, the 22.2 and the 18.015, are going to be multiplied, and then the answer from that will be divided by the number on the bottom, which just so happens to be 1 mole. The answer that we get from this is 399.933 as our numerical value. So 399.933 is the answer that we get from our calculator, but we need to report our answer with respect to significant figures. Because we're multiplying here, the number with the least number of significant figures is going to dictate our answer. So 22.2 is the value that has the least number of significant figures with 3. So our answer is going to be 400 with a decimal point at the end. That decimal point at the end indicates that the zeros that we have here are in fact significant. So 400 written in this manner is representing 3 significant figures. Now, we also need to report our units. Okay, so we need to do a unit analysis just like we have in the past. Moles of H2O and moles of H2O on the bottom are going to cancel out. What I have left over is grams of H2O. So my answer is going to be 400 grams of H2O. So what I've done here is I've converted from moles to grams by multiplying by my molar mass and subsequently completed the question at hand.